I mean, if you take a really, really high-level view, multi-agent interaction is basically like essential for AGI, right?
Yeah.
We're all doing multi-agent interactions now, right? We're all agents, right? So in one sense, like if you want agents to be close to this level of intelligence, they need to be able to handle multi-agent interactions, right?
Well, thank you everyone for coming. As many of you know, this is actually the second session of Greylock's Change Agents. Change Agents is a new series that we're hosting that explores what it means to be building agentic software. And we're doing that through conversations with researchers and CEOs who really are living these problems every single day. I'm Corinne Riley. I'm one of the partners here at Greylock, and I focus on early stage B2B enterprise infrastructure and applications. And tonight I'm joined by Karthik. Karthik is the head of research at Sierra and associate professor of computer science at Princeton. I'll let him give a more fulsome introduction of himself. But yeah, welcome to Change Agents.
Oh, thanks, Corinne. Thanks for having me here. Hi, everyone. I'm Karthik. Like Corinne said, I lead the research team at Sierra. I'm also an associate professor at Princeton. Short intro is I've been working in this field that we call agents for quite a long while. I'm really excited by the potential of agents to really impact, real world and help us solve real world problems. A bit of background, I think before we call it agent, I mean, we're calling it agents now, but like most of my work in a technical sense has been around the fields of NLP, natural language processing, reinforcement learning. So I've been doing that both at my time as a faculty member at Princeton, and before that as well, where I had a short stint at OpenAI for a year, where I was lucky enough to be involved with the very first GPT model.
Perfect. And actually, that perfectly goes into the first question, which is, like you said, you've been working in this area for about 10 years, and now we all use the word agent every single day, and if you open LinkedIn, every single post is about agents. But if you read back to your research, back to 2015 and everything that you've done until now, a lot of it is around this concept. So maybe actually walk us through a little bit more detail on the work that you've done. And then actually, why don't you give everyone, we have some people from Sierra in the crowd, but actually give us a description of Sierra and what you do there.
For sure, yeah. If you want to start with agents, I think, many people here probably know, it's sort of like, you can go back all the way to the beginning of AI in some sense, as where the term agent was coined, right? So an agent is not just an AI agent. Like all of us are agents, right? So an agent is basically something that can affect change in its environment, right? And so the way I tend to look at it is like, when the field started, this was a dream, right? Build autonomous agents that can accomplish things in the world, whether it's physical, virtual, whatever. And we sort of realized very quickly, through the 60s and 70s and 80s, that this is a very hard problem, right? And so we split up into these different fields, computer vision, natural language processing, RL, and all of that. And for me, it was always like right from the time I was introduced to AI and NLP and RL, it always seemed like these are subfields working towards the same thing, but just trying to solve parts of this holistic problem, right? And it's super exciting now because we have language models that do really well solve problems that have been longstanding in NLP. We have agents that that from the reinforcement learning sense are also like working really well, and we can work towards like combining these two and have agents that both understand language, can communicate with humans and all of that, but also actually do things in the real world. And so a part of this is what we're trying to do at Sierra, right? So for those of you who don't know, at Sierra, we're trying to build real world agents for the enterprise, starting with customer support as like one vertical. But you can see it's a tailor-made problem for AI agents to really help us automate parts of this, right? So in customer service, you're basically having these interactions where you need to communicate live with a human who is sharing information with you, often in a partially observable kind of setting, right? You don't get all the information in one shot, so you have to have multiple rounds of communication. And at the same time, you have to figure out what actions need to be done on the back end, whether it's like changing your flight reservation or walking through a radio refresh or whatever it is, right? So it has this nice mix of these two things, right? You need to understand language, you need to process language, you need to generate language, but at the same time, you need to take actions that affect the state of the world in some sense.
Perfect. And so today we're going to divide our conversation into 3 broad topics. The first is just agent capabilities. What can agents do well today? And you have a really great framework that you've spoken about in the past about this. The second is, building agents in the real world and what that looks like. And lastly is, looking at the frontier of agents, what you see coming in the future. And so starting with agent capabilities, you have this framework that you've spoken about in the past of, we're shifting from language models to language-enabled agents. And, you talked about a sequencing of key capabilities into 3 parts. Part 1 being, we have language agents that can reason and act, and that ties closely to your React paper. Part 2 is agents that can learn new skills through language in addition to just doing and experimenting. And then part 3 is the point where we can actually control agents with natural language and have really great guardrails around them. And so walk us through this 3-part framework that you came up with, and why are these the dimensions that you think matter?
I would just add, it's not something that I came up with necessarily. I mean, a lot of other people have also thought of this. I think this ties back to what I said just now, right? The goal of these different subfields of AI have always been to move towards autonomous agents. And for me, it's always been useful to think of it as a synergy between language capabilities and decision-making capabilities. So that sort of plays into this, right? So when much of the field is thinking about, NLP has a lot of different problems. You can think of question answering, information extraction, all of that. But the end goal for all of that is to be part of a larger system that actually does things, right, in the world in some sense. And so the 3-part framework you can think of as at the very core, you want agents to, you want basically the systems, let's not use agents for a bit, right? Autonomous systems to both use language and be able to take actions. And so that means leveraging the synergy here, right? So in reinforcement learning, we've often had this concept of taking actions, getting feedback, getting rewards, and then taking better actions, learning from that whole thing. But language provides us a mechanism for reasoning or thought, right? I mean, that's just one mechanism. You can argue other mechanisms exist, right? And so reasoning and acting seem like a great fit straight up there, right? So using language as a mechanism for just writing down your thoughts, reasoning through it, all of that. This is something intuitively we do as humans, right? And that was sort of the basis for the React kind of framework. The other 2 parts are actually something that's quite close to my heart. The part about learning from reading is something that we do a lot, right? So think about we were born, as children. There's so much that you need to learn. A part of what we learn is by just trial and error, right? And this is the basis of reinforcement learning. You try things, you try to hit the tennis ball with your racket, keep trying. First 10,000 times you're bad, and then you start to get better and so on. And so that's the basic premise of reinforcement learning. But if you really think about learning efficiency of how we learn as humans, if we only did trial and error, we would never be where we are right now, right? So there's also this component of learning through just reading about things, right? So, and this is how we sort of share experiences amongst each other through generations and all of that. And ideally, for a very intelligent agent, it should have the same capability, right? So in this tennis example, this would be something you have a coach that looks at how you're playing and tells you, hey, maybe hold the racket up a little bit further up or something like that, right? And so that sort of takes away lots of cycles with this trial and error process. And so that's something that I think we need to have AI agents do the same thing. And that's more within our grasp right now because language models are just so good at processing text right now. And a majority of our world's knowledge is on the internet in the form of text, right? And videos and so on, but still, a lot of it is in text. And then the third part, which is again, this is something that's not new, right? So we all want to be able to, as humans, as a human race, we want to be able to develop these agents, but we also want them to do things for us. And for that, our natural mechanism of communication is through languages. And so we'd want to be able to express whatever we want these agents to do in free-form natural language, not have to code it up in very, very specific forms, right? This just leads to more natural interactions.
And if you think about 1 and 2 in particular, right? This is a purposely difficult question, right? If you were to give us a score of where we're at today on our capabilities on 1, right, to do that synergy between reasoning and action, and then also on part 2, which is to understand based on language, like where would our ability in agents score today?
It is a hard question. And I think it depends on the task.
Okay.
If I were to just give like one number just for fun, right? I would say on number 1, the ability to reason and act reliably, maybe like 50 out of 100. But the one about like learning from reading and being able to do that very fast, maybe very lower, like 30 or 20. There are probably some tasks where like you can quickly get it and be able to assimilate that, but it's hard to say.
And what's going to bridge that gap?
That's a good point. I think for the reasoning part, we're definitely on a trajectory towards making these models smarter and be able to like navigate enough of the uncertainty in the way that language models decode and all of that. I would suspect, like, I mean, a part of this answer goes towards like better data and how we train the models and all of that. But actually, there's an interesting part that I think could be even more important is just how we structure the environment to be able to facilitate this kind of learning, right? And so, just as a high-level summary of that thought is basically, we've had notions of environment and agents and all of that in the field of reinforcement learning for a very, very long time. Mm-hmm. And I think a lot of those notions can be challenged or revisited simply because we're in a totally different paradigm to where we were in the 80s or 90s.
Okay. And that's why you're working on that at Sierra?
Partly.
So let's go into the second core topic, which is building agents in the real world. And you often talk about the evals of agent being one of the core bottlenecks, right, to getting something in production and one of the most immediate challenges. And actually, if we think about the 2 most cited or even use cases for agents today, people always think about customer support and then they think about coding, right? And actually, you've worked on the 2 probably most important benchmarks in those areas, right? So SWE-bench for Sierra in the customer support space, and then SWE-bench as well in coding agents. So maybe let's start with SWE-bench actually. Walk us through that, right? And how does it work for Sierra? And obviously, it's been used even past Sierra, and I think it's been cited in Anthropic's work as well. But yeah, walk us through your work there.
Yeah, I would say this comes back to the point I made about environments, right? Mm-hmm. So, like I said before, at Sierra, we're building agents for the specific use case, at least initially, of customer support. And so the way that SWE-bench came about was like, as you know, like, in order to build good agents, you always want ways to measure their capabilities really well. And there's been a ton of work in the space of dialogue systems as well as like agents for web-based tasks, web shopping or whatnot, right? And so what we were trying to do was really come up with good systems to benchmark the agents that we're building, both internally but also like broadly for this space in an academic sense. And this was an interesting story because like what we realized was like while there exist both these spheres, dialogue systems and web agents and all of that, there wasn't something that really was in this missing part or gap in between, where you sort of want multi-turn dialogue, but you also want to be able to like take specific actions, and the information is revealed to you in sort of like this like partially observable / adversarial setting, because sometimes, as you know, customers don't want to tell you everything, right? They just want the issue solved in like 2 seconds. So that kind of led to us creating this benchmark. And so I think it's also the right timing because, language models just are so good right now that you can do things like simulating the user in a much more realistic fashion as opposed to how it was like even like 5 years ago.
Yeah. And like, do you envision, let's say I'm starting a company, I'm in the audience, I'm starting a company today, not in the customer support space. obviously it's case by case dependent, but like, do you envision a world where like companies like Sierra need to build their own benchmarks continuously? Or like, what do you think evals looks like in the gold standard, steady state world?
I think for any systematic methodology that you want for improving your agents, you do need to have some kind of a benchmark or some kind of a metric to measure against, right? So in that sense, yes, you would definitely have to build evals. But I think evals is maybe is a sort of vague term for this. I would actually say like focusing more on the environment in which you want your agent to act, because that is a little bit more than just like evals, right? Okay. Because you want to also think about the actions that your agent can take, which are called affordances, right? Or the signals you want to feed it, which are the observations in some sense, and then how you also determine the reward function in some sense. So you want a combination of all those.
And then you also, obviously, as I mentioned, worked on SWE-bench, and I think any of us following the coding world, a lot of times SWE-bench gets cited as like a criteria that you're really marking yourself against. Yeah, what do you think? And then a lot has changed also since SWE-bench was first released. What do you think of what looks like the future of evals, particularly in the coding space? And if you were to do SWE-bench 2.0 today, how would it be different?
Yeah, I think coding is a very interesting use case, right? We've had, just to recount the story of SWE-bench, we've had like lots of benchmarks for coding, right? And many of them focused on the task of actually just producing code, right? So you sort of have a prompt. How well can you write this function that reverses a palindrome or something, whatever, right? You have this particular setup. But if you take the task of software engineering is much more than coding, right? In fact, you spend probably like 20% of your time writing the code, 80% debugging it and doing all the other things. And so that's how the idea for SWE-bench came about, like being able to say, can we test these models and agents later on at their ability to take a piece of code base and then take an issue and make the surgical change to this code base based on whatever the issue, the bug or something, whatever you have is telling you to do, right? I think that was a good start now almost 2 years ago, right? And I think we've made a lot of progress, which is great to see, right? So initially, those models were less than 10%, I think, on this, but now we have close to 70%.
Yeah.
And I think that's great, right? In terms of like making these models more applicable for the real world, and like we're already seeing, companies like Codium and Cursor and all of these like benefiting from this. As for a V2, I think we should just pull on this thread a little bit more, right? So thinking about what are the different aspects of the life cycle of a SWE type role would look like, right? You could imagine like going up levels of abstraction, right? So fixing a bug still seems like a one surgical thing. What if you could take 100 bugs and figure out what are the refactors necessary to do something, right? So there's lots of ideas. I think you can go levels of abstraction. You can think of different modalities. There was a follow-up that was more on like multimodal SWE-bench and all of that. So yeah, there's a lot to be done, but I think like it's just, once we have this kernel, we can go in different ways.
Yeah. And so let's talk about the second part of building in real life here is the orchestration side of things. So there's a number of frameworks available, open source, or for purchase. How do you think about how you connect all this together? And I'll leave that open-ended, and then we'll go into more details.
I think the frameworks are definitely useful to start thinking about how you can connect the different components you want in your agent. But I think the bigger question just comes back to how you sort of structure your environment and how you want the agent to operate in that environment. So what I mean here is, like I said, like the small things like determining the affordances or the observations that the agent take are probably more important in my mind than the actual framework you use to like orchestrate them. In the sense that most of the open source tools available right now are basically doing similar things, right? It's sort of like just like an abstraction layer that provides you a little bit more ease of writing the code to define the agent. Yeah. But the real thing that you really want is something deeper beyond that, right? So how do you make sure that you have that right balance of control, but also you don't want to work too hard to define the agent, right? So you want that.
And actually, this is exactly the next question, which I was calling it like budgeting agents, right? And so, when we think about orchestration specifically, our understanding is, an agent has the capability to keep on iterating on a task until it gets to completion and finds a result. Now, we've seen in products, this capability to kind of like budget an allowance for how much you should think, right? And really set a cap on what the agent should be doing or how much it should be iterating. And I think even Anthropic released like the think tool, so you can exactly tell it when to stop and think about what it's doing. Now, how do you think about whether that works? And then also as it relates to a customer, right? Like you said, often you're dealing with a frustrated customer. How does that impact like the UX from a customer using your agent perspective?
Yeah, I think from a technical perspective, you can always look at the results around like test time scaling and the ability to use like trade-off, I guess, more compute at test time for basically more accurate or reliable answers. It depends on really like where we put the test time compute on, right? It's in the paradigm, I think there's still like a lot of headroom for us. Like we've still not like fully exhausted it. But you can also imagine, right, at some point, just thinking more doesn't solve your problem.
Yeah.
Either it's an issue with like the information you have, or the actions you can take, or something like that. So I think this is a trade-off to be had, and in different domains, like you'll have to think about this, right? There are costs associated, just like you said. Like it might increase your latency or the cost of what you want to do. But one thing for sure, I think like. There's a lot of research to be done in terms of like how do you actually like distill those behaviors back into ways that don't affect those different paradigms.
And do you find that customers want that level of granularity, or are we still far away from them even wanting to kind of determine how much the agent thinks or how much it iterates?
I don't know if that should be a knob that the customer decides or not. That's
Okay.
a different question. But it could be, yeah.
So actually, let's connect this back to Sierra, right? And so if I think about simplistically a customer support workflow, right? I think of the old way of doing it with standardized SOPs, with tree decision making. And so if I think about that, I can easily imagine a world where you can chain some prompts together and have an LLM do that. So why is it that agentic reasoning is useful to Sierra or to customer support in general?
I think there's maybe two reasons for that. So one is around you could hook up some kind of a loop and have build a quick demo, right? So but one of the key challenges I would say is like the reliability of an agent is in the real world is very different from building a demo quickly, right? And I mean, TowBench was like the whole point of TowBench is actually to showcase that, in one of the dimensions. And I think part of this comes down to LLMs being not fully deterministic systems, right? And they're still not at that level where all the different answers that you generate from this probabilistic inference are actually correct, right? So there's still like lots of paths where even a single token can lead them astray and all of that. So I think there's this like one issue of how do you ensure reliability and repeated accuracy, right? That's not easy if you just like build it with like a loop and add some tools, which is exactly what we show in TowBench. And the other part I would say is like at the same time, you don't want to, just like you said, you could try to manually write down the whole SOP in some sort of decision tree, but that just goes back all the way to like what we had in like Shrewdloo and all these old systems, right? So this would just be like too much work to maintain and even just like build an agent that can handle all these nuanced, tail end cases. So you sort of want this right balance between like ease of use and specification. How do you basically build the agent very quickly, and at the same time like have it reliable enough? And I think that's what we're doing at Sierra, like having this right combination, such that it's a delightful experience for the customer, but it's also like a very, very scalable, reliable way of building agents.
And actually, yeah, that goes perfectly into how do you make it customizable for agents? And maybe even just abstracting that even further, if you think about the way agentic products can and should work, right? Should they be customized to every single customer? Or do you think that there's like a generalizability that we can achieve such that the next 100 Sierra customers can really be adopting this in a very similar way?
Yeah, that's a good point. We do have something that we call the Agent SDK or Agent OS, which has these modular components that can be easily composed in different ways for building new agents. So that's exactly part of the thing that we make to ensure that it's not like a tedious process where you're building an agent, but at the same time you get that guaranteed level of reliability that you want in the actual agent.
So let's go to the last topic, which is kind of frontier regions. And in this topic in particular, one of the things I want to talk about is multi-agent interaction. And this is something that you've spoken about in your lectures prior. And people bring up all the time. I actually was texting a friend of mine who works at a very large tech company that we would all know. And they say, our customers ask us all the time if we have multi-agent interaction available. And then you press them on why they exactly want it, and there's no real reason, right? But it's something that people have talked about enough that it's in the common lingo of customers. Now, if we asked probably everyone in this room of how they would define multi-agent interaction, I bet we would have 40 different responses. And so maybe turning it over to you, what do you think multi-agent interaction is? Let's start with that, and then we can go deeper.
If you take a really, really high-level view, multi-agent interaction is basically essential for AGI, right?
Yeah.
We're all doing multi-agent interactions now, right? We're all agents, right? So in one sense, if you want agents to be close to this level of intelligence, they need to be able to handle multi-agent interactions, right? But to go down a bit more, concrete, right? I think of it as you always want to have some kind of asymmetry between different agents for it to be truly multi-agent, right? Mm-hmm. So if it's just you take, you could even consider the prompt of two different agents to be different, mm-hmm. But that's it's a little bit shallow, right? Yeah. So you basically have the same model underlying, and you just prompted them in different ways. Technically, you can still call that multi-agent, but it just seems a little bit
A lot
shallow.
of people are, I think.
Yeah. I think cases where it could make more sense are, there's some kind of knowledge asymmetry. Let's say, you have two robots and, one is in one corner of the world gathering some input sensors and one is in the other corner and they do something. Or in the more, less physical sense, you could even imagine, places where information is just sort of guarded due to privacy concerns, or let's say different companies have their own siloed information, but you want agents between them to be interacting with each other. That's when you truly need the protocols for agents to communicate and figure out how they want to work together and all of that. I think we'll start seeing some of these soon, these use cases, but
why do you say that? Yeah, what use cases are on the horizon? What makes you believe that?
Oh, I just say this from a more high-level overview point. The fact that we're all we're living in a multi-agent simulation ourselves. And so if you want agents to act in the world and be together, work together with humans, they would also have to work together with each other. And so you talked about, agents taking on SWE tasks or coding tasks, right? Or agents performing customer support. At some point, you'll have these different functions needing to communicate with each other, whether within a company or across companies and all of that. And so I don't think we can avoid it. And it has to be on the path to AGI.
And what needs to happen to get there, or maybe even more granularly, where is it going to come out of? Is that something that your team at Sierra can work on and get done very well in your context, or is that something that needs to come out truly from the model layer?
Which part? The need for multi-agent?
The ability for these agents to be communicating and acting in tandem.
Yeah, I think it shouldn't be a forced sort of thing. You should have a clear reason for having a multi-agent setup, right? And just like I said, there's likely some sort of asymmetry, whether it's skills or information or something that enables it. If it seems forced, then you're probably better off having a single agent.
You should probably not have it in the first place.
That's just my,
Are there specific use cases that Sierra or in customer support more broadly that you think are valuable for multi-agent?
I think probably not specifically for Sierra, but like probably the use case I can think of that would likely be true enough is that you just have information that's like guarded behind walls, and you have to have some way. I would say in some sense, like you can argue protocols like MCP are moving towards that. You want to hide some information away. At Sierra specifically, like without going too much into detail, we do have some systems that sort of do this guarding, like in terms of guardrailing the whole process and making sure the agent doesn't do things you don't want it to do, right? So you could argue that that's part of that framework.
And then I'm going to ask one parting question, and then I'm going to open it to the group. If there's any questions from the group, please speak up. My parting question is you've had an incredible career both in academia and in industry now. If you were advising, a younger student on what they should go research, like what they should focus, their academic life on, what would that be? And then I'm going to ask you the same question of what you're excited about in industry.
Okay, so the first one is on like working in academia. I think there's a ton of things. I think the high level point is to embrace the current state of technology and to think forward a little bit, right? So to give you an example, I think one of the things where I think there's still a lot to be done is in thinking about what is the next, thinking about continuously evolving or learning agents in general, right? So I mean, right now what we're building are basically, you have some kind of a underlying model and you're orchestrating it to do, automate some set of tasks. But how do we think about these as continuously evolving and autonomously learning on their own over time, right? And so this is where, like I said before, right? So notions of things like reinforcement learning that we've built over decades might need to be reinvented or even rethought of. And in fact, I think David Silver and Rich Sutton had a paper recently that talks about a little bit on this, like the era of experience, right? I think that's along the same path. I think this is a very fascinating topic, and honestly, like there's so many different ways you can attack it, and I think that's ripe for something you can look at. From the industry standpoint, I think there's just a lot to be done in still making this transition from agents that demo really well to agents that actually work in the real world. And a lot of this may not be, something that requires a completely new paradigm shift. Some of it will be, but a lot of this relies on figuring out the right problems you want to solve and measuring them and making these systematic sort of changes or improvements. I think that's where focusing on the things that really matter, right? So customer support is it's not like you're having 2 conversations with a user, right? You're having millions of conversations per day, and even for a very specific conversation, you're having the same kind of radio refresh happening 10,000 times. And you don't want even like a 0.1% failure rate there is actually 100 conversations. You don't want that, right? And so focusing on these aspects of what makes agents actually tick in the real world is super important to increase industry adoption and make sure we actually leverage this technology.
Great. Okay, are there any questions from the audience? Yes, right.
And then also, sorry, sure. I'll just repeat the question. What does your day-to-day look like as head of research? Also, if you're adjunct at Princeton, how are you managing the split between that? And then also, just can you walk us through what the different parts of research are that you guys are working on at Sierra? As in, for example, you're talking about guardrails, right? So you probably have some safety people that are doing research there. You probably have some people that are working on industry adoption, working closely with the engineers. What are all the different teams? What are the sizes of the teams?
Maybe I'll answer the last part first, because that ties
into
the day-to-day. We have a ton of problems that we're trying to solve, right?
Can you give some examples?
It's again, coming back to this whole, the overall goal is to make it easy to develop agents, but also we want the agents to be really good and really reliable, right? Mm-hmm. So I would say our research efforts are kind of split between the two. There's efforts that go around how do you think about making it easier to build agents, right? Without going into too much detail, you can think of leveraging a lot of automation to do that, right? And then the other part is around, how do you make it easier to test the agents? How do you make it easier to build the agents? What are the components, like the core parts of things like Agent SDK that actually make it better, right? This involves models and all of that. There's a little bit of both, right? That ties back to much of the day-to-day, right? So there's parts about like thinking about these different projects and how we move forward on all of these, but other parts are not, different parts on like things like recruiting and more ops or different things, right?
What about like reading papers, going to conferences, talking to professors, and like within those categories, like can you be a little bit more concrete about like, because I think like pretty broadly, those are two very big categories that every company's working on, right? Like how do you build agents, how do you evaluate them? Like what are some like very specific categories that your researchers working on?
That's a good part. So one of the things that we at Sierra definitely want to do is, in addition to doing research that benefits internal products, we also want to give back to the community, right? That's how TAO-bench is a paper. We're working on other papers that hopefully come out soon. And so you're definitely right in the sense like there's a lot more papers now on archive or whatever, different channels that you get your papers from. And it can be quite hard to like sift through these different ones. We do have like sort of like reading groups to go through that, but again, like there's a lot of like a noise, and you want to sort of sift through and get the signal to noise ratio. I think it helps to be somewhat focused on the sort of problems you're trying to solve that are relevant, right? Okay. But also with an eye towards like things that can cause a big shift, right? So I mean, I don't have like a panacea for like how do you pick the papers or anything like that. I mean, it's just like part of what you decide is important.
And then we have another, okay, we have a bunch of questions. I love it. Okay, in the pink in the back, Krista, thank you.
Yes. Hi, I work on productionizing AI. So my question was, what are some challenges that you've seen in deploying agents on-prem versus on the cloud?
I don't think we deploy agents on-prem. So our agents are all on cloud. So I don't know the answer. Yeah, the difference between the two.
That's very interesting because customer support is so often like when they're legacy enterprises, they have on-prem, like they want on-prem deployments. So is there like something shifting in the industry?
I think if you, I don't know the answer to that question, but my sense is like you are handling requests, right? And as long as like the data flows through the approved vendors, then it's fine for most of these cases.
Okay, more questions. Oh my goodness. Why don't we just go there?
Oh yeah, I was really curious about like TAO-bench particularly. I hadn't like heard the paper before, but like I kind of like took a look at it like during the talk. So I guess there are like a few like kind of like technical aspects of it I was curious about. Like I think this is the first time I'm seeing like kind of a multi-turn like agent setting like done as a benchmark where like the user, like the standard for the user is a language model. Yeah, I was like kind of curious like what kind of like failure modes like you guys saw for like the user like stand-in language model. I think I didn't like see too many like examples of that in the paper. I was like also curious like you kind of mentioned like simulating like the adversarial aspect of like the user where like they're maybe not like giving you all the information like right away or like they're like kind of withholding stuff like even accidentally. Yeah.
Yeah, there's actually a huge, I actually suspect like we can do a lot of research in that as well. Like how do you make a user realistic enough? I mean, like you can argue that a user is also an agent in some sense, right? And you would want to like simulate at the very top level, like you almost want an entire world model to be able to simulate the user, right? So there's a lot of challenges there. You're right in that like the user being a language model causes some issues. We are working on some of those, like reducing issues caused by those, for example. Yeah, I think the other part of this is like sometimes you can also think of the flip side of this is because it's such a it's a setting where like the release of information from the user is not like everything at once, right? So sometimes mistakes are fine as long as the agent can handle them, right? Everything is plausible within the space of the plausible things happening in the universe, right? So I could just be a bad user and say like, hey, I want to cancel my flight or whatever. And then next step, I can be like, actually, no, I don't want to do it, right? That is plausible, right? So your agent should be able to handle that situation. And so as long as you think of it that way, some of those errors don't really cause such much that big of difference.
Let's do 2 more. Is there one in the front here, Krista? We'll do these 2 front ones. And then
In the RL context, do you think using language models as your sort of initialization takes us away from purely experiential learning, such that they have maybe like a ceiling because of the inherited kind of cognitive heuristics of humans?
I don't have a definitive answer to that, but that's a good point, right? For what it's worth, like we were doing this purely experiential learning for quite a while, right, as a community, right, learning from nothing. And I think it's definitely, like, from the evidence that we're seeing so far, right, having a basis of, like, base to start off with, like, which need not be read everything on the internet. It could be something lower. I don't know the answer to, like, where that threshold is at which we can take off. But you could argue, like, part of it is, like, wired in our DNA, right? So where does that information come from, and how do you have the equivalent? So I definitely think it's, like, practically it makes a lot of sense to start from language models and do it. The question of whether it limits us at some point, TBD.
do you want to pass it right there?
Hey, so I wanted to ask about the more real-time reinforcement learning that you were talking about. I know that OpenAI and a couple other services have come out with this reinforcement fine-tuning, right, where there's very little data that actually is required to fine-tune a model, and you use this LLM as sort of a base that continually learns. Have you guys actually implemented that in production or experimented with it? Yeah, and what type of data actually goes into it? I know logs are something that is very useful, where you can just extrapolate a lot of information from something very little. So yeah, just curious about that.
I think there's a part of this which is like, how do you do the overall thing in general, and then one part was like specific to Sierra, I think. For the latter, I would say there's experimentation going on. For the former, I would say DPO is just like one way of thinking about it, but more broadly, right, you don't always want a human to go in and label what is preferred, right? You also want to be able to like define reward functions on the fly, or like you want the agent to figure out like, hey, a bottle falls down and it breaks. That's a bad thing for certain reasons, but it's also a good thing. It can be a good thing situationally, right? How do you think about that, and how will we learn for agents, right? So like as a human, you have this entire stream of consciousness, but you're still learning in an episodic sense. But they're both compatible. Whereas in RL, normally you think of it as like episodic, it ends there, and then like, okay, you just restart. So there's some shift that needs to happen there when you think about continuously learning. That's what I meant.
Great. Great. I know there's more questions, but unfortunately we're out of time, so that concludes the panel. However, the Sierra team is going to be posted up in the corner over there, so if you guys want to see a demo or learn more about what it's like to be working at Sierra, they're more than happy to tell you more about that, and we have more than a few members from the team here. But thank you everyone for coming. Thank you for Karthik for the talk, and yeah, really appreciate everyone being here for Change Agents.
Thanks for having me.
Great. Thanks.